Hi guys, so here we're going to talk about the two most important concepts in chemistry. They're electronegativity and reactivity. You'll need your notes, table S, as well as the periodic tables. So we're going to talk about what electronegativity is, its trends across a period and down a group, as well as reactivity. So electronegativity is how attracted an atom is to another atom's electrons. So say, for example, we had hydrofluoric acid, all right, so an H and an F, so hydrogen and fluorine. Electrons will be shared or can be transferred between hydrogen and fluorine in order for a bond to actually occur. So we knew before that fluorine has 7 valence electrons and hydrogen only has 1 valence electron. So if I were to show this, I can show a simple little dot diagram, which will go more in depth later on. But I can show here that fluorine has 7 electrons, hydrogen has 1, so they're going to share that electron and share those 2 electrons to form a bond. So pretty much it's how attracted this atom is versus this atom for electrons. And that's what electronegativity is. So if we look here on this table, hydrogen has an electronegativity value of 2.10. These are arbitrary values. They don't really have any units. They're just pretty much relative to one another. Fluorine, on the other hand, has an electronegativity of 3.98. So really, fluorine, since it's a bigger number, it has a greater attraction of electrons. In fact, it's going to, take more of hydrogen's electrons, and either in a bond if they're sharing or transferring electrons. But more of those electrons will hang around fluorine because it has a electronegativity value of 3.98. Now, according to New York State, on table S, this value is actually 4.0, and that's fine. It's around the same number, as long as you know that fluorine has the highest electronegativity. Now, let's scan around. Which one has the lowest electronegativity? We should see the opposite end, francium, has the lowest electronegativity value. If you also notice, the noble gases don't have any electronegativity values because they don't tend to share or transfer any electrons. They have a full valence electron shell or energy level, so they're pretty much set to go. We just think about any of the other atoms instead. So of course fluorine has the greatest electronegativity, francium has the least electronegativity. As you go up, the electronegativity value increases, as well as if you go across. So if we, again, the electronegativity value increases across the period until you hit the noble gases, and that's because there's a greater nuclear pull. That fluorine's nucleus is going to attract more electrons of another atom. As you go down, we decrease the the electronegativity value. And just to remind you of that, think about francium versus hydrogen. Between the two, francium has the lower electronegativity value. And that's because of increased shielding. Since there's so many more energy levels between the nucleus of francium, so if we have so many more energy levels, there's a greater distance between the valence electron and that nucleus. So there's not as much nuclear pull going on in there. Now, this all deals with reactivity. So the electronegativity is how reactive, or pretty much how likely an atom is to bind with something else. So how an atom will exchange electrons with another atom. So group 1A and 7A are the most reactive, and noble gases are stable, so they actually don't have any reactivity. So if we look down at the next slide, we can actually see that the lower left-hand corner, which happened to be francium, and the upper right-hand corner, which was fluorine, are the most reactive. They're going to be very likely to either share or transfer electrons. So to summarize, electronegativity is the attraction of a nucleus to another atom's electrons. Down a group, the electronegativity decreases due to more shielding. Across a period, it increases due to more nuclear pull. Fluorine has the greatest electronegativity, and francium has the least electronegativity. Have a great day, guys.